This is video 11 for Math Lesson 1.7. This lesson is about square numbers. Take a look at the math message question that you just completed. You were asked to use counters to try and make a rectangular array with an equal number of rows and columns for each number, 14, 16, and 18. And then the question, which numbers make this kind of array? What did you discover? If you found that the number 16 was the only number of those three that you were able to make an array with an equal number of rows and columns, you're absolutely right. Now, if you look at this array, we've got a 4 by 4 array. Now, a 4 by 4 array is very similar to a square. It has the shape of a square. If we wanted to, we could draw a square around this array. It has an equal number of rows and columns. There are 4 rows, 4 columns. When an array has the same number of rows and columns, it is shaped like a square, so it can be called a square array. Now the number that this square array represents, the number 16, is called a square number. This is the part that you need to copy down into your notebook. So turn to your next empty page and your title is Square Numbers. Okay, write square numbers at the top. A number that can be shown as a square array. Now if it's a square array, remember it's going to have an equal number of rows and columns, like the array for 16, a 4 by 4 array. 4 rows, 4 columns. All square numbers can be written as the product of the number times itself. For example, 16 can be written as 4 times 4. Many times square numbers are written in exponential notation. For example, 16 could also be written as 4 to the second power. We call that 4 to the second power, or sometimes we say 4 squared when the exponent is a 2. We say it's squared. These are two different ways that you can write 16 as a square number. Make sure you have this copied down before you move on. You might need to pause the video. Now let's think about what it means if we're looking at square numbers. Okay, for example, if we have 1 squared, what we see is 1 row, 1 column. If we write the number sentence, it would be 1 times 1. That equals 1. That's the first square number. 2 squared means that there's going to be 2 rows, 2 columns. 2 times 2 equals 4. Now 2 squared is another way of saying or naming the square number 4. There are 4 total boxes, but they can be arranged into 2 rows and 2 columns. 3 squared means that we have 3 rows, 3 columns, for a total of 9. So 9 is a square number. 4 squared means we'll have 4 rows, 4 columns. That's the square number 16. 5 squared means we'll have 5 rows, 5 columns. 5 times 5 equals 25. So 25 is the next square number. 6 squared means we'll have 6 rows, 6 columns. 6 times 6 equals 36. 36 is the next square number. If you look at our products here, these are the first square numbers that we have. 1, 4, 9, 16, 25, 36. What would be the next square number? Right, 7 times 7, 49. Be careful when you're working with exponents. Sometimes fifth graders tend to get these numbers a little bit confused. For example, let's take this this number expression that's in exponential notation, 2 to the third power. Okay, the base number is 2. That's our larger number. The exponent is 3. That's the little smaller raised number. What that means when we're looking at 2 to the third power, that base number 2, that's the number being multiplied. Okay, so 2 is the number that we're multiplying. Our exponent 3 tells us the number of times the multiplication occurs. So it means that we're going to take 2 and we're going to multiply it times itself 3 times. So what we get looks like 2 times 2 times 2, which is equal to 8. We took our base number 2 and we multiplied it 3 times. So we have it down here 3 times. Okay? A lot of fifth graders get confused and they think that this is 2 times 3, but that's not correct. 2 times 3 would be 6, and that's not the right answer. 2 to the third power means 2 times 2 times 2, which is 8. If you need extra practice working with square numbers or especially exponential notation, you can look on page 6 in the student reference book, and it explains exponential notation a little bit more. It gives you a few more examples.